Alright, hello, welcome back to another TouchDesigner tutorial. It's UV here. I hope you're all doing good. So yeah, in this tutorial I'm gonna cover the 3D Physarum simulation and component that I've recently developed. And I'm still developing, to be honest. This system looks very nice, but I feel it's not perfect yet. And there is a lot of stuff that I would really want to improve. But yeah, you can do really nice stuff with it. So yeah, let's dive in. First of all, I want to explain a bit about the algorithm and how I implemented the third dimension. So my resources were obviously the 2D first of all, there's this article by Jeff Jones, which covers the whole idea behind the Physarum algorithm and the way basically the particles or agent moves and different patterns that they make. So if you want to have more sense about how it works and diving into the algorithm, you can totally read this, and yeah, it really helped me to understand. There is a 2D docs file inside the derivative website, which also helped me a lot to understand what's going on. And I just thought about how to add the third dimension. There is a tutorial in YouTube that uses, I believe it's Houdini, that also expand the theory and also implementing 2D and 3D simulations. So it has like 3 parts over here. I highly recommend you to watch it also. And this GitHub by Barblot, which also implemented 3D Physarum in shaders. So this code also gave me the structure and the idea of what I need to do. And yeah, so here is an example of like one thing that is not yet, I don't have any solution for it right now, but you see, after a long time it just decays. I have some thoughts about why is it, so I will jump inside the component. I will explain. So generally the Physarum works like this. You have agents, particles, they have initial positions, and around each of these particles you have sensors. And the sensors basically sense the trail of the other particles that they are leaving basically behind them, kind of a trail. In texture context, it's just like pixels which are white or black, or between white or black. And we start the simulation with random position, and the sensors are basically taking back the render, the trail, and sampling it from their location, and based on that we decide which sensor got the maximum value of trail between 0 and 1, or just the maximum value, and based on which sensor got it, we turn the agent or the particles to the rotation angle that we choose. So in 2D you have only three sensors. You have the sensor that is basically straightforward from the particle position, and one to the right and one to the left, and you can choose the sensor angle. That basically changed the whole structure of the simulation. So in the third dimension we have also up and down, so top and bottom basically sensors, and you can also do like right top, right down, and basically, you know, put more sensors, but this is like the basic, I think, like right, left, and up and down. So in 2 dimensions it's pretty much straightforward, because you just render your simulation in a 2D texture, and you take it back to the simulation engine, or like the GLSL top, and sample from the coordinate of the sensors. But in 3 dimension we need an extra data to figure out where is the trail of the particles located in the Z dimension, or the 3rd dimension. So for that, what we use here, it's a 3D texture. Let's go inside. So the structure it goes like this. We have initial position that you can choose later in the component which one, or just use yourself your own initial position. We have an initial direction of which the particle will be in, and here we are sampling back 3D texture. Okay, this comes from here. Okay, so here we compute the simulation, and we have our new position and our new direction. Here we have attractors that we will cover later. Boundaries, if we want to bound basically limit the positions. And here all of this goes to the render. And this is the important part. Let's see what's going on here, and let's also open the parameters. Cool. So sorry, yeah, so here we have our positions in 3D space. All right, and then we need to render them in a way that we can feedback them into the simulation and determine the trail, basically values. So for that we basically convert the positions into 3D texture, and let's see what's going on here. So in TouchDesigner you have a feature that you can render the simulation like regularly. So I'm just doing like a simple instancing of this texture with boxes, and I render this, and I can also here in the image tab output a 3D texture based on my resolution and the depth, and with the render select I can select that image. Okay, don't mind this error. I'm not sure why is it erroring for something, but it still works. This system I took from Vincent house TouchDesigner talk. He talks about 3D textures and he shows this technique. So we have our render and then we got our 3D texture of that render. So basically each slice here, it's a slice in the depth. And then we are doing some process here, which is basically blurring and multiplying it. So it's like the diffusion, which makes the blur, right? And evaporation also makes it like this. So it really, you can see it's like changing the way it looks. And the trail repulsion, it's also a parameter that I'm using inside the simulation here. So what else? So yeah, we have like a simple render over here. I'm also rotating the particles to the to the direction of movement, and you can turn it off or not. So if you're using like more like long particles like this, I think I exaggerated. So if you don't have the rotate to, it looks a bit weird, but also nice. But like this, it feels like really nice. Yeah, so let's go back. I hope my explanation was good enough for you. If you want to get more into 3D textures, I highly recommend to watch Vincent Hou's TouchDesigner talk, and he covers a lot of more other stuff. So about the component, let's see what's going on here. So we have a reset, we have a step size, so we can make it go fast or slower, and also make it go fast. It's changing also the way the particles behave, relates to their rotation and everything. I highly recommend you to play around with this, because you can have like different structures based on the movement, like the step size. So number of agents, currently I'm using only this number, but if you have a better computer, so you can pump it up, and it will probably make the simulation works much more better. I believe the decay will it will reduce the decay. The volume size, it's just like the volume size, which is, oh, sorry, yeah, I think I need to fix that, but yeah, it's just the volume size. So you can make it like this, play around with it. In the 3D texture resolution, if you have also a better computer, you can pump it. I don't have yet a crazy computer, but I will soon. So this is basically applying to the 3D texture over here. So the more resolution you have, the more data you get, and the simulation will behave better. But let's keep it like this for now, because my computer will make noise and you won't hear me. Map, it's the basically if you want to use user initial position, let's say, so you can just map your texture like this and just put it over here. Make it 32-bit float also. Yeah, so you can put your own initial positions, like something like this, you know. So you have a box, you have a sphere, and you can scale them also. You have the agent, wait a second, the agent position, which applies to the position to 3D texture here, to this box. So it's also changing the way the 3D texture is reacting. So if you make it bigger or slower or smaller, you see it's like changing the way it's reacting. Let's keep it to 1 right now. Random rotation probability, you can add some tiny probability if you just put like a small number here, and they will also like have a bit of random movements. Don't exaggerate like this, because it's will break it. But I found out if you put a bit of randomness, the simulation will stay a bit more stable. Yeah, let's leave it like this for now. What else? The rotation angle of the agents, so you can also change it, and it will basically change. Let's make them you know what, let's keep it like this. So yeah, the rotation angle is affecting also, and also the sensor angles. So it's the way the sensors are rotated around the agent. In the article, basically they put it like this, I believe, and it makes like a nice structure. So you can definitely play around with it. The sensor offset, it's basically the sensor's position distance from the agent. So it's also affecting the simulation quite a bit. Boundary shape, so we have box, we have a sphere, and you can also initialize it as a sphere, make the sphere smaller, and it will like kind of grow like this. Let's maybe make it like this and slower. Yeah, something like this. So it grows like slowly. You have also oh, the radius sphere also, but if you change this radius sphere, it's like will crop it. So like if you want to change the size of the sphere, just do it here in the render. I mean, if your volume is 111, so the sphere radius should be 0.5. But if your size is like bigger, so you should make it 1. Yeah. Anyway, these things I need to also, I think, fix a bit. But yeah, let's continue to the what is limit. So you can use like zigzag and clamp, and it's like kind of like making a different look, like with those box shape. And loop you don't have, because loop it's like box, it's like reacting as a limit with loop. Alright, so diffusion, we talked about it. It's like blurring the trails. Evaporation, it's like also affecting the trail, and it makes like more kind of like clusters. And also the trail repulsion makes those clusters. Alright, so now let's talk about attractors. So for the attractors, you can just use a noise, and let's have one attractor for now. Make it 32-bit float, not monochrome, and let's call it attractors position, and just drag it over here, and we have our attractor. And now the attractor color effect, it's like on, so yeah, let's leave it like this for now, and we can animate the noise to make the attractor move. Let's say something like this. Reduce the harmonics, and you have the amount of force. You can make it bigger. Let's, yeah. So it's not attracting right now. Basically, it's like I don't know why I call them attractors, because they're not attracting right now. But if you put a minus over here, they will attract. I believe. Yeah. Yeah, this is too much. Anyway, yeah, they kind of attract. Yeah, but I like it to be positive. Make it a bit bigger, like this. And you can, of course, add more. And the colors, you can also add some colors. So let's actually, let's copy this, call it color, and we're just not gonna animate it right now. And let's choose like nice colors. really nice. And the attractor color effects, it's like doing this effect that basically it's based on the distance of the attractors, and you can threshold it and also soften, and this is like how dark the particles are, and yeah, and the light of the attractor. So you can make them like this and something like this. Yeah. Alright, so that's it for this and the render. You have okay, you can choose not to render, and then you can take the position of the agents, the rotate to vector, color, and attractor position, everything you need to render basically. And if you want to render, you can just render. You can open the render network and play around with the light, for example, and you can do like more processing, post-processing. Oops, sorry. Let's change it to a sphere. So you can change the resolution, of course, scale the particle or agent, so you can make them smaller, and now they are basically a square, a box, and so you can change it also inside over here. Go to agents and change the type of sub. You can choose not to rotate to, you can translate. I need to fix the translation, I think, because it's like, oh no, it's fine. It's up, down, yeah, cool. You can rotate around the axis if you want, and scale it also. Yeah, what else? I think we basically covered everything. Yeah, so I'm gonna improve this for sure, and probably will add more features, I believe. This is something that I want to do, but there's still a lot of things you can do with it, and really hope to see you use it and enjoy it. So thank you so much for your support, and see you in the next tutorial. Bye bye, have a nice day.